All right, so we are supposed to determine S for the RL load, so our load is the resistor and that inductor, given those values for that particular circuit. And so the first thing that we would do is see, we already have everything in phasor form, and so if we wanted to figure out what what V was, let's see, because our best way, so the way I like to find the power is, I know that there are different formulas, but I prefer just to use the straight up one that has that it's 1/2 V AB I conjugate. And the conjugate means that, well, we take the conjugate, you take the opposite of the imaginary part. So there are lots of different formulas, but this is the one that I like, because it's just, the power is VI or IV that we've learned all along. And then the 1/2 is because of the fact that it's not root mean square. If it was root mean square, we wouldn't have the 1/2 there. And then the conjugate part is part of dealing with AC power. So let's see. I would have that if I wanted to figure out the voltage across this, so if I wanted to figure out the voltage across that, I know that I could use current division to get the current through that part, and then voltage division, and then just get the voltage once I have that current. So let's see, if I had current division would tell me that I on RZL would equal the other impedance, which would be ZC R1 over ZC plus R1, because they're in parallel, over the total impedance. Oh yeah, you can't really see that. Okay, so that color's bad. But that's just as well, because that was going to be too complicated. Let me come up with a better way to do it. Let's see, so okay, so the voltage across this, so the voltage across our current source is going to be the same as the voltage across R1, is the same as the voltage across ZC, is the same as the voltage across this whole branch, because they're all in parallel. So just using V equals IR or V equals IZ, then I can say that my voltage equals my current source times all of these things in parallel. So ZC in parallel with R1 in parallel with these things, which are in series. And so that is the same as saying, I was about to use the same bad color, that's the same as saying when I have more than one thing in parallel, I would say it's 1 over ZC plus 1 over R1 plus 1 over R2 plus R plus ZL. So do you remember that with when you have more than two things in parallel? Okay, so then I can multiply both sides by this denominator here, and I get 1 over ZC plus 1 over R1 plus 1 over R2 plus R plus ZL times V equals IS. And so that would be 1 over ZC was minus J20 plus 1 over R1 was 10 plus 1 over R2 was 5 plus R1 plus R is 10 plus ZL is J20 times V equals, and IS is 4 angle 0. So then I can just find that value. So 1 over negative J20 plus 1 over 10 plus 1 over 5 plus 10 plus J20 equals 0.124 plus 0.018 plus J.018 V equals 4. So V equals 4 over that number. So 4 divided by second answer is 31.59 minus J 4.58 equals V. All right, so now, let's see, so let's get, so that's V across the whole thing here. V across just RZL is only going to be a part of that. So V across our load, V across RZL, and we'll use voltage division on that, is going to equal R plus, well, it will equal this voltage that we just got times R plus ZL over R plus R2 plus ZL, or that 31.6 minus J 4.6 times R was 10 plus J 20 over 5, or 10 plus 5 plus J20. So I'll take that answer that I just got times, and then my fraction will be 10 plus J20 over 15 plus J20. And I get 23.5 plus, or 28.5. 28.5 plus J 1.0. Okay, so that is my voltage across R and ZL. So that's my VAB. So VAB equals 28.5 plus J 1.0. Our current is going to be of that voltage times the impedance, so IAB, so this is just V equals IR, is just 28.5 plus J 1.0 times 10 plus J 20. So that answer I just got times 10 plus J20. So that's my current, 265 plus J581. $265 plus J581 is my current. And so my power will be 1/2 times VAB, which is 28.5 minus J 4.6 times I conjugate, which is 265 minus J 581. Somehow that number seems awfully big. Let's see, so what did I do wrong there? Oh, I should have, V equals IR, I should have divided. You'd think by this point in my career, I would know that the current is the voltage over the resistance, but okay, that was silly. So it should be 28.5 plus J 1.0 divided by 10 plus J 20. And this time I get 0.61 minus 1.12 J. So then my power will be 1/2 times 28.5 plus J 1.0 times 0.61 plus 1.12 J. Now it's usually not worth it because typing in the conjugate's not that hard, but there is in the complex number menu, second complex, there is conjugate. So I could just say, take the conjugate of that last answer times 0.5 times, was it 28.5? What was the voltage?
28.5 plus J 1.9.
Okay. So I need to put that in parentheses. 28.5 plus J. And I get 8.135 plus 16.25 J. Let me convert that to polar. And I get 18.18 angle 63.4. And this is the total power, and so that is in VA, would be my units.